This is a review of the QRPme 2-tin Tunas Tuna Power System kit, as built and reviewed by me, Davey, KU9L. A QRPme fanatic. The newest version of this kit consists of 5 12-volt outputs via the classic RCA connectors, a Molex 4-pin connector, and one USB connector. The QRPme kits typically come sealed in a 307 can, which makes a great chassis. You must pull the tab open to start inventorying parts. Although this kit is intended to complement the 307 can, contains the circuit board to be soldered as well as the bag of parts inside. The cans are designed as interconnected to other kits or standalone as required. The circuit board is professionally laid out and debugged so you get a kit that works as expected, when assembled with the correct part placement. There is a pull tab on the can. It leaves behind a rim that supports the circuit board. Be careful, as this rim is often very sharp to fingers rubbing on it. Once the lid is pulled open, the bag of parts can be observed. This is how I look when inventorying my QRPme kit parts list. You can also use your cell phone to expand out the camera image, which zooms in on those real tiny parts. This is how I look when I have determined my kit may be short a component or two. Carefully go over the parts list again, to be sure there is a missing part. This is how I look when I have located the missing part, or have found the needed part, in my own inventory, where I have an assortment of basic parts. I have bought an assortment of 1/4 watt, half watt. You can use the 307 can for a stable form to solder onto. You can also use your favorite method of board holder like the QRPme pads. QRPme has lots of nifty tools created to save time and frustration during assembly. Good tools make the job of assembly go much more pleasantly. Follow the assembly guides closely if you are a new kit builder, watch the soldering videos, and helpful tips and advice given freely by Rex. The Build of Materials guide groups components in clusters. This TPS project kit will power 5 other kits, plus power a USB, and a Molex connector with +5 and +12 volts of power, all simultaneously. The transistors and voltage regulators have heat sinks to run with cooler temperatures when using the USB or the SLA charging section. It was suggested that if you wanted to charge at a higher level than 1 amp, to replace the diode with a 1.5 amp model to work the UC3906 NIC harder. I chose a 1N54043 amp diode. First, to do this model, here is a close-up of the complete project before it is installed into the 307 Tuna can. The heat sinks can be checked for proper fit. It was suggested to mount the TIP32 transistor and its heat sink to the bottom of the board to aid in giving proper access to all of the power connectors. Make sure you observe pin polarity and that the heat sink is parallel to the circuit board, so that it does not accidentally short the circuit points on the board. The charging circuit was designed for 18 to 20 volts of DC input. From testing the solar input, I was able to get a full 1 amp from the solar panel in bright sunlight, proportionally less in overcast weather. It was difficult to monitor all ports at once, so I decided that I needed to add Anderson power pole connectors and simple voltmeters to see the action. Now I can quickly monitor what is going on and extend my operating time by adding a little solar to the equation, and can charge my Android phone. The 4-pin Molex connector can power my Pentec TR35CW QRP4 band HF radio. 72 and 73 from Davey, KU9L. Work you POTA soon.